Question 5 from section A. Here there is a field. There are two dielectric medium of permittivity epsilon 1 and permittivity epsilon 2. A charge is placed Q plus Q placed at a distance d from the plane separating two dielectric medium. To solve this, there are two situations. Case 1, finding solution for z less than 0, that means for this region, and case 2, finding solution for z greater than 0. We usually solve this by method of image, which tell for case 1, finding solution for z less than 0, we place an imaginary charge in this region at a distance d prime with q prime image charge, and it has to solve the Poisson equation and satisfy the boundary condition. If you go through the proper derivation, you can follow. If you want to go through the proper derivation, you can follow the Jackson book chapter 4. Here I am showing the q prime. If you go through the derivation, you will find q prime is comes out to be a function of q and epsilon and 1 and epsilon 2, which is epsilon 2 minus epsilon 1 by epsilon 2 plus epsilon 1 times q. Similarly, for case 2, to solve this, to find a solution in this region z greater than 0, we place an imaginary charge q double prime at a distance d double prime from the plane in this region, and we will find, if you go through the derivation, q double prime turns out to be 2 epsilon 2 divided by epsilon 2 plus epsilon 1 times q. So we can look at how the field lines would look like for these situations. Here, let's look at here you can see the field line for z greater than 0, you would expect, since there is a point charge, the field line would behave like this. It was always positive, so it would behave like this in this region. For z less than 0, there are two situations. Q prime, whose magnitude is positive. Another situation, its magnitude is negative. If the magnitude is positive, you can see case 1, there is a plus q charge here. There is a positive q prime image charge. You would expect the field line in this region would kind of behaving like repelling, like you would expect it would behave like this. However, if there is the charge is negative, you would expect the field line would attract, and you would expect the field line would look like this. And this is only possible, the q prime induced q prime charge is negative when, you can see from this formula, epsilon 2 is greater than epsilon 1. And if the image charge is net magnitude is image charge q prime is negative, then the induced charge, which is physically the charge will be induced on this surface, and its net charge would be negative, and here it would be positive. So the correct option is, since the field line from the in the question, you can see the field line is attractive, it seems there is an induced or there is an image negative charge, and you would expect the field line is attractive. So correct option is option A. Question 15. As you can see, there is a configuration of charges. For this problem, you can do a multipole expansion. If you want, you can refer to Jackson. Their first contribution will come from the monopole term, which goes as 1 over r square, and this term will not contribute as the total charge is equal to 0. Then the next higher order term is the dipole term, which goes as 1 over r cube. The electric field corresponding to the dipole term goes as 1 over r cube. You can see the dipole term, if you take each component, each will cancel out. If you sum up the dipole term, you will see the net dipole moment is 0. So this term will also not contribute. Next we will go to the quadrupole term, which goes as 1 over r to the power 4. And if you compute the quadrupole term Gij, which is equal to 3x I x j minus r square sum over qi qk, then you will see this is not vanishing, so this term will contribute. So correct option is option A. Question 18. Hydrogen atom has a decay rate from n is equal to 2 state to n is equal to 1 state as about. The decay rate is given by 6 into 10 to the power 8, and you can find the lifetime is equal to 1 over decay rate, which is equal to 1 over 6 into 10 to the power minus 8 second decays per second. If the energy level expression for the hydrogen atom is this, uncertainty in the wavelength of the emission would closest to how much? We can use uncertainty relation delta E delta T times delta T less than is equal to h bar by 2. Here you can see delta uncertainty in the of the lifetime is of the order of the lifetime. So if we substitute, we will obtain the uncertainty in the energy is got by 2 delta tau. Now E, the relation between E and the wavelength is delta E proportional to hc by, or E is equal to hc by lambda. That implies uncertainty in delta E is equal to 1 over by E is equal to 1 over 1 over lambda square, the uncertainty in lambda by or in wavelength by lambda. So you first substitute all the values here, obtain the uncertainty in E, then substitute uncertainty in E, and E is equal to here E2 minus E1, and substitute here, and you will find delta lambda of the order of 30 pentaban this one. Question 14 from section A. An electron beam is accelerated over a potential V and strikes a crystal with lattice constant 5 angstrom. What is the minimum V needed to resolve the crystal? The minimum V to resolve the crystal, the de Broglie wavelength associated with the electron should be less than the lattice constant less than equal to the lattice constant in order to resolve the crystal. So minimum case you could take lambda E is equal to 5 angstrom. This is the maximum wavelength associated with the electron for which you can resolve the crystal, and you can find the relation between the energy and the de Broglie wavelength as 2m2me kinetic energy square root, where kinetic energy of the electron is equal to EV. B is the applied voltage potential. So if you substitute all these numerical values, lambda E is equal to 5 angstrom, Planck constant, mass of electron, and the kinetic energy, you will find the potential is of the order of 5 to 6 volt. So correct option is A. Question 11. Consider a single particle in a potential well with energy spectrum En is equal to Ne. For n is equal to 0, 1, 2, 3 up to infinity, with epsilon greater than 0, the nth energy level has degeneracy. A Gn is equal to 2n plus 1. The system is at temperature T. What is the value of Hamiltonian what is the average value of the Hamiltonian? So we can compute this Hamiltonian each average is equal to, or we can say summation over n goes to 0 to infinity En Gn e to the power minus beta En divided by summation over n is equal to 0 to infinity Gn e to the power minus beta En. If we substitute En, we will obtain n is equal to 0 to infinity Ne 2n plus 1 e to the power minus beta Ne divided by summation over goes to 0 to infinity 2n plus 1 e to the power minus beta Ne. Solving further, we will obtain summation over n is equal to 0 to infinity 2n square e to the power minus beta Ne plus summation over n goes to 0 to infinity Ne e to the power minus beta Ne divided by summation over n goes to 0 to infinity 2n e to the power minus beta Ne plus summation over n is equal to 0 to infinity e to the power minus beta Ne. Here we will solve this thing. Let's say x is equal to e to the power minus beta E, then summation over n goes to 0 to infinity x to the power n, as we know, is equal to 1 over x. If we take the first derivative, summation over n is equal to 0 to infinity n x to the power n minus 1 is equal to 1 by 1 minus s to the power whole square. If we multiply, that implies n is equal to 0 to infinity x to the power n. If we multiply x on both sides, we will obtain x minus 1 minus x whole square. We need this one 1, 2, and if we take another derivative, 0 to infinity x to the power n n square x to the power n minus 1 is equal to 1 minus x to the power whole 4 1 minus s to the power whole square minus x 2 1 minus x plus. Solving further, we will obtain 1 minus x to the power cube 1 minus x plus 2x minus 2x square, which is equal to, that implies summation over n is equal to 0 to infinity n square x to the power n, multiplying x on both sides, we will obtain x by 1 minus x to the power whole cube one plus x minus, just a second, x to the 4 x to the square, so this is not correct. 1 minus x plus 2x equal to 1 plus x. So we will take these three equations 1, 2 and 3 and substitute here. As you can see, the first equation is 2e. I can write this one as e to the power summation over n goes to 0 to infinity n square e to the power or x to the power n, and I will substitute this relation. Here x is equal to 1 minus beta x into 1 plus x by 1 minus x whole cube plus epsilon n x to the power n summation over n is equal to 0 to infinity. We can write, use equation 2, x by 1 minus x to the power whole square divided by 2 times x by x 1 minus x whole square plus 1 by 1 minus x. Solving further, we will obtain x will cancel 1 or 1 minus x take e 2 x 1 plus x minus x into 1 minus x divided by 1 by 1 minus x whole divided by 2x plus 1 minus x divided by 1 minus x. This will cancel out. So we will obtain 1 or epsilon by 1 minus x 2x minus x x square three x square minus plus x divided by x plus 1. which is equal to epsilon by 3s square plus x divided by 1 minus s square, where x here is x is equal to e to the power minus beta I. If we substitute here, we will obtain epsilon 3 e to the power minus 2 beta I plus e to the power minus beta I divided by 1 minus e to the power minus 2 beta I. So if we divide e to the power minus 2 beta I on both numerator and denominator, we will obtain epsilon times 3 plus e to the power minus e to the plus beta I divided by e to the power minus 2 beta I plus minus 1. Made a mistake probably. Here if we take this one is actually plus, I made a mistake here. This one 2x plus x times 1 minus x. So if this is plus, then this would be 3x minus x square, plus s square so this would be 3x plus x square, so this would be minus 3 beta I 2 beta I. So if we divide on both sides, on numerator and denominator by e to the power minus 2 beta I, we will obtain epsilon 3 e to the power beta I plus 1 divided by e to the power 2 beta I minus 1, which is the correct option is A. So I made a mistake here, I corrected. This should be plus. Question 10 from section A. Scientists are conducting an underground experiment where two interactions A and B can occur. In general, interaction A is twice as likely to occur compared to interaction B. Interaction A would give a signal in the detector with a probability 1 by 8, while interaction B would give a signal with probability 1 by 2. If the detector registers a signal, what is the probability the signal was due to interaction A? Let's say PA is the probability for interaction A to occur. Similarly, PB, probability for interaction B to occur. Let's say eta A, probability that interaction A would probability for interaction A to give signal in the detector. Similarly, eta B is the probability for interaction B to give signal in the detector, and let's say PIA is the probability that interaction probability that a signal in the detector is a signal in the detector is due to interaction A. And let's say there are n number of signal detected in the detector, then total number of signal due to interaction A is n times PA times eta A divided by PA times eta A plus PB times eta B. Similarly, number of interaction due to number of signal due to interaction B is n times PB times eta B divided by PA times eta A plus PB times eta B. So as you can see, total number of interaction is Na plus Nb, which is equal to n. So the probability that a given interaction or a given signal in the detector is due to interaction A is total number of, or the fraction of A interaction due to or we can say the number of signal due to interaction A divided by total number of signal in the detector. And if you substitute, you can get PIA is equal to PA times eta A divided by PA times eta A plus PB times eta B. So if you substitute the value, PA is equal to 2 times PB, eta A is equal to 1 over 8 divided by 2 times PB times 1 over 8 plus PB times eta B is equal to 1 over 2. You can solve it 1 over 4, you can cancel PB, 1 over 4 plus 1 over 2, which is equal to 1 over 3. So correct option is A, which is 1 by 3, the probability. Question 14, this is the question from electronics. You can see the circuit. This is an op-amp, and there is a transistor. This is the collector current IC, let's say. This is the base current, and this is the emitter current. Here the relation, the beta is equal to 120, which is equal to IC divided by IB, base current. And the relation we know, the emitter current IE is equal to IB plus IC, or IE is equal to IB 1 plus IC by IB, which is equal to IB, which is equal to IB 1 plus beta. We will use this relation later. Let's say first find the emitter current. As you know, the principal op-amp has a high gain, very high gain. So it adjusts the output such that the voltage at the non-inverting terminal is equal to the voltage at the inverting terminal. That guys, voltage at this terminal Vi minus is equal to 5 volt. For this circuit, voltage at this point is 5 volt. We can compute the IE here. IE is equal to 5 by 47. We got IE. Here we can obtain the IB, the base current which is asked to find, is equal to IE divided by 1 plus beta, which is equal to 5 over 57 divided by 121. If we solve, we will obtain this close to 0.00879 something, which is equal to this ampere, which is equal to which is equal to 0.88 milliampere. Correct option is this one. Question 8 from section A. There are 3 rooms. Each has a detector. Each has a smoke detector. In case a smoke is detected, the detector output goes to a logic state true. And to prevent a false alarm, these outputs are connected to a logic circuit whose output activates a single alarm. As you can see, there are D1, D2, D3 detectors output connected to this logic circuit, and there would be an alarm or alarm whose output is true. This is only possible when you can see all these the circuit has only one type of logic gates, that is the NAND gate. These are NAND gate, and its truth table is when both the input are 0, x, y, z, then the output is 1. When one is 0 and another is 1, output is 1, 1, 0, 1. When both the input are true, then the output goes to false. This is the output that will is true, that will activate an alarm, activate the single alarm. So let's say this is only possible when this input is false, both the input are false. Both the input are, yes, if input is false, and this is only possible when both these are true, input is true. That means here you can see D3, the alarm will activate only if there is a signal, or if the D3 detector detects a smoke. And this is true, then this should be either true, both true, another is false, another is true. You can check all the combination, both false, and similarly you can find all the combination for D1, D2. So as you can check if you check the options, then you can see only option A has the smoke is detected in room 3. That must satisfy in order to activate the alarm. So this option is correct. You can also check if there is a smoke detected in room 2, then that would also activate the alarm. So this option A is correct.